Okay, hello everyone, and thank you for joining the State-of-the-Art Developments in Glass Recycling, sponsored by Alfred University. We're really excited to talk to everybody about some of the developments in glass recycling in New York State and some of the opportunities and challenges that remain for MRF recycling in the state. I'd like to thank Alfred University for sponsoring the event and hosting. It's been very helpful for them to help us proceed with this presentation. They've also done a lot of work in figuring out different types of markets for recycled glass. So my name is Whit Gatchell. I'm the CEO of Refuse Recycled Materials, which is a Rochester-based recycling company focused on capturing industrial minerals from municipal and industrial waste streams. And I'm joined by two co-hosts who are going to present today. One is Cynthia Andela from Andela Products, and Richard Smith, also from Andela Products. And we're also having a final presenter from Alfred University, Aaron Potter, who's going to present some opportunities for new emerging markets for waste glass. So we just have these four presentations, and then afterwards we'll have a Q&A for 10 to 15 minutes. Which we'll let you guys do some asking any questions that you might have. And in order to ask questions, the best way for you to do that is to go into the Q&A box at the bottom of your screen and just type in questions. And once the presentation is finished, we will start answering some of those questions. So with that, I can go ahead and start the first presentation, which is me from Refuse Recycled Materials. I'll just quickly share my screen here. Okay, as I mentioned, my name is Whit Gatchell, and I am the CEO and founder of Refuse Recycled Materials. Refuse Recycled Materials is a Rochester, New York-based startup urban mining company focused on recovering industrial minerals for municipal and waste streams, in industrial waste streams, excuse me. This includes glass, along with other things like gypsum and other types of industrial minerals. So let's try to get an overview of the overall problem in New York State. New York State produces roughly 500,000 tons of post-consumer container glass, and more than 50% of this ends up in landfills. You can kind of see a breakdown here of where the glass is going. The deposit redemption programs account for about 200,000 tons annually. The curbside and MRF programs account for about 250,000 tons. And other is just the tonnage that ends up being lost in either put directly into trash cans or is lost as it's being processed by MRFs. So this is despite there being a lot of opportunity and value for this material. And some of the reasons that MRFs are unable to connect to these valuable markets are: one, single stream recycling. I think all of you know that single stream recycling presents a challenge because of the mixed nature of the stream. So just the basic cost of having to sort through everything and get the valuable material out and to markets is quite a challenge. In addition, broken markets, there's not a lot of access or knowledge about what types of markets are out there. A lot of the markets for glass especially are dispersed, whether it's the cullet market or glass sand markets or other types of markets. In general, it's a high cost material to deal with. It's heavy. It takes a lot of wear and tear on the equipment at individual MRFs, and is just generally a challenge to handle. In addition, there's limited infrastructure and patchwork infrastructure. Some of the MRFs in the state have beneficiation technology, but many do not. In fact, the majority do not. And there's all kinds of different types of equipment that are out there, different types of funding programs that MRFs access. So there's a really kind of a patchwork across the state. There's also, in addition to that, there's some policy headwinds that I want to point out. One of them is the bottle bill from 1983, which is in the process of being updated. And as of when I checked yesterday, it was still in committee. And the basic challenge is that it remains a 5% deposit, which hasn't reflected increases in inflation obviously since 1983, and that results in a lot of waste in this. In addition to that, there's a regulatory loophole, which I think anybody that's a MRF operator probably knows about, which is being able to utilize the recycled glass as a landfill cover. And then in general, there's kind of a lack of data and accountability for where the glass is going. Alfred University has actually done a lot of work, as well as other institutions in the state, to kind of figure out where exactly this glass is going, but I think it still kind of remains opaque, and that presents a challenge for where this glass is actually being produced and where it's going, and then trying to intervene to put it into different markets. So as I mentioned, there's kind of a market paradox here where MRFs have this valuable material that is only growing in demand. These are kind of some of the factors driving that. It's not. I think it's important to remember that it's not just a market for cullet, which cullet is used in the production of glass bottles. There's also other end uses for this type of material. And one of those is industrial sand, which is the one that I focus on with refuse materials. And industrial sand is commonly used in cement, abrasives, filtration sands, and as supplementary cementitious materials or a cement replacement. And there's roughly 130 million metric tons of industrial sand consumed in the United States annually. Some of the market drivers are buy clean or ESG programs, where people are trying to replace the mine's commodity with other sources. Despite that demand, this is particularly true in I would say in the cement, somewhat in the fracking industry, definitely in abrasives and filtration sand. There's a lot of market demand for alternatives to that mined material, which is only increasing in cost. But there's limited to no infrastructure to connect or process the potential sources of recycled sand with the actual end buyers. So MRFs in general face a challenge in reaching these new markets, including glass sand. One of them is dispersed customers. Large customers of industrial sand and cullet need consistent supply and volume and quality. And then smaller customers typically need specialized bagging or other types of specialized distribution. As I mentioned before, there's uneven capacity. Different MRFs have different levels of capacity in terms of actually how they handle glass and process it and what they can produce. Distance and logistics are a major challenge, just because of how heavy this material is. Oftentimes, hauling this low value material doesn't really make sense. It adds to the cost, and it's difficult to find buyers. And then in addition to that, there's no real buyer network like there is for other commodities in the glass market. There are some, but it's still very disjointed, and there's not a lot of opportunities to connect directly to buyers. So here's some of the shifts that are creating new opportunities in the market. As I mentioned before, there's a bigger, better bottle bill working its way through the legislation right now. Still in committee. It's been there for a while. Kind of unclear what exactly is going to happen there, but that would basically raise the charge to 10 cents per bottle. The second thing is the EPR, which has funding capability for MRFs for their upgrades, and gives it access to individual MRFs for funding through the state. The DEC and Alfred have put together an R&D pipeline as well, which we'll discuss a little bit later, which is looking at new and emerging markets for glass, which I think is really great. As I mentioned before as well, shifting priorities, public procurement, especially from the Department of Transportation or from other government agencies, and just private demand for green infrastructure is really driving a lot of demand for recycled products. In addition, this one is kind of specific to glass sand, but there's a BUD exemption currently in the law for glass sand, which does not require an individual BUD certification as long as it is less than 5% non-glass content. So I think right now the market is at a very big inflection point, which, you know, is basically policy plus funding plus market pull is creating space for regional processors to localize glass supply chain. And that's what Refuse Materials is currently working on. So Refuse is planning to fill the market gap by providing a cost-effective solution for waste glass processing in New York. You know, the basic idea is being scaled for efficiency and optimization in order to meet the cost demands of our end customers. And that requires just utilizing, you know, kind of basic infrastructure to do the glass processing. It also requires really thinking about optimizing supply chains and how we deal with transportation. You know, obviously, when you're dealing with a bulk material, you really need to focus on the cheapest way um, to transport that material, which is often by rail. If you're trucking too far, it can be really not cost effective. In addition, we're looking at ways to standardize the material so that large purchasers of industrial sand will be interested actually in the end product. And that requires obviously processing technology. And then the final piece of that is entering into long-term supply agreements, both on the supply side and on the demand side, which I think are beneficial to both types of customers and suppliers. So this is kind of the basic breakdown of the business model, which is you know, municipal glass waste producers, you know, producing their glass product, in addition to commercial waste producers looking at C&D waste here, commercial glass manufacturers, and potentially alcohol industry, which is often excluded from the bottle bill. That would then be transported to a clean glass facility, which will enter into long-term offtake agreements with major producers, sort, clean, treat, and mill the glass until it's, you know, reaches its until it reaches a form that is suitable for a market, and then just a way to centralize processing and marketing and those business relationships. And so the primary markets for glass sand that we're looking at are in the cement industry, basically in the production of cement. There are about 5% of a cement mix uses industrial sand, and we're looking to replace a certain percentage of that. And then in the secondary markets, we're looking at abrasives, filtration sand, landscaping, which could also be backfilled for construction, and pozzolan feed, which pozzolan is just used as a cement replacement, but they require large amounts of relatively clean glass that they need to process further into their specialized materials. So this is our kind of pilot solution that we're working on, which is a Western New York solution, basically connecting Buffalo, Rochester, Syracuse to Albany, and kind of utilizing the existing rail network there. We're also working on setting up a hub in Albany, which would do the final cleaning. So in order for this type of system to work, it would require MRFs to have a basic cleanup system at their facilities, and then move that glass to the rail line, sending it to Albany, where it would be fully cleaned up, and get ready for bulk distribution to our anchor customer and also to secondary markets, which often require specialty bagging and distribution. So we have identified one potential anchor customer in Albany, which is the cement plant Holcim Ravena, which uses quite a bit of silica sand annually. And you know, we'd like to replace you know, a percentage of that sand that they are utilizing. And then the secondary markets, we've also identified several partnerships that we can utilize to distribute into the filtration and the abrasives market as well. So the goal is basically to create a repeatable model, hub and spoke model that solves Western New York's glass issue, and that can be replicated across the country in markets where there are gaps. So that's my presentation. I think I'd like to hand it off next to Rick Smith, from Andela, who is going to give an overview of some of the engineering technologies available for glass cleanup.
Thanks, Whit. Get this going. All right. Good day, everyone. I'm Rick Smith, the engineering manager at Andela Products in Richfield Springs, New York. At Andela Products, we primarily build glass recycling machines and equipment. We've been in the industry for over 30 years, and we are a global company. We serve uh, places all over the world and all types of companies, small communities, businesses looking to recycle glass, different countries that have different problems with their waste glass, resort islands, and many more places all over the world. So we handle different types of source waste glass. There's glass coming from the material recovery facilities. We call those MRFs. You can see a picture of MRF glass in the top right corner there, which is always laughable. Unsorted glass bottles, bottom right, it's just a pile of maybe multi-stream or source separated glass containers. We have mixed bottles and containers that we have to deal with. We have plate glass donations, such as through a Goodwill or another Salvation Army or other donation areas that take plates and bottles and glass. But any frangible material, and we'll talk about that later in the slide, but any kind of material that breaks down, ceramics, glass, plates, dishes, porcelain, that's source of glass waste that can be used, as Whit talked about, downstream, making sand and other products. But today we're going to talk about MRF glass residue. So there's a picture of a pile of MRF glass residue from a site that's processing it and getting the glass out of it. So what is MRF glass residue? Well, it's the residue that comes from a MRF that still has valuable product in it, valuable glass source in it, but also contained in it, there's food waste, dirt and other organics. There's small plastic pieces, aluminum, steel that didn't get sorted at the MRF processing center. So there's other still valuable products on top of the glass. There's non-recyclable items that people throw in. They think they're doing the right thing by throwing those in their recycling bins, but they're really not recyclable, and they need to be landfilled. And then, of course, what we're after here today is the broken glass, which gets embedded in the residue or is too small to sort. Some characteristics of MRF glass are it's typically 2 inches and smaller. And that's coming out of the MRF itself through a screening process. But as you can see in this picture, there are larger pieces of non-recycled material included, plastic lids and tops that have slipped through the screening process at the MRF. Typically, this MRF residue is 70 to 80% by weight glass, but 10 to 20% by volume. So there's a low volume in here, but a heavy weight in this product. And then, of course, the percentage of organics varies greatly from MRF to MRF and from season to season. And the moisture content in the MRF residue glass varies wildly too, based on the MRF and also the season and also the processes of covering and storing. This is just a real simple flow diagram of what we're trying to accomplish with some of the equipment we're going to talk about. We have waste glass or dirty cullet, and we want to get the glass out of it, and we want to separate out the material we don't want. So the first step is a screening process. We have trommel screens, which are rotating screens that I'll show you here in a picture shortly. But screening processes do what the MRF did in the beginning. They try to take out the debris, but we do it at a much more refined level. So the debris, the paper chaff, the fluff, the other particles that we don't want, we try to get out through the screening process. And then the cullet comes out cleaner. And then it's processed again and processed again until the cullet is at a certain level of cleanliness that it can be sent downstream for further processing. So this is a really basic flow diagram of what we're trying to accomplish with the MRF glass residue. This is a very simple cleanup system. where no size reduction takes place to the glass. So whatever the glass size is in the current scooped up MRF glass, we're basically just trying to blow off any of the debris we don't want or screen out any of the debris we don't want. So in this case, the MRF glass is supplied to a conveyor at the very front end. And sometimes we use a hopper, a metering hopper, to contain the flow or control the flow of material through the system. But then it falls into what we have is called a trommel screener. And in this condition here, we have two large cage blowers, and basically they're blowing off the material that we don't want. And it's kind of a density separation. It's blowing off the paper, it's blowing off the plastic, it's trying to blow off any of the lighter weight material that we don't want to continue to process. And then the glass falls into the bunker below, and then that can be scooped up and sent downstream for further processing if necessary. Or at this point, depending on the clients or depending on what the next process is, the cullet can be moved out of sight. And this just gives you an idea of the size and scale of a system that we've developed. This is a particular glass cleanup unit, and it does a very similar thing. So all of these processes will have a common theme. They're trying to sort and separate the glass from the non-desirable materials. And so in this case, another blower system is used as the mixed product passes by that airstream, and it attempts to separate again the paper, the plastic, and the fluff that's in the glass. And these are other technologies that are in the market, and again, very similar in processing. People use shaking tables. They use a lot of air jets, air to move the product, to loft the product, basically using the density difference between plastics, paper, and glass to help get that separated, and by size as well. If the larger particles are paper and plastic, we can size them off. This is an image of a more complex system that Andela has provided to a customer. It does more than the simple system. The primary thing that it does is it starts the glass size reduction process. So in this system, we have a feed hopper in the beginning, and then a cross belt magnet to try to pick off any of the ferrous materials that may still be in the MRF glass residue. And then it enters into a pulverizer, which we'll talk about a little bit more detail, which does the glass size reduction. And then it enters into a trommel screening system. And out of there, it is further classified through a gravity or a density separator. And then we also in this model have an eddy current, which helps us pull off any aluminum that may be still in the MRF glass residue. So a much more complicated system, but it demonstrates sometimes the complexity that we have to go through to clean up the MRF glass. And then also in this one, we have an automatic recirculation loop, again, to continually refine the product until it gets to a certain level of clarity to be exported out of this process onto a downstream process. This is the Andela pulverizer, which we've been doing for quite a long time. And it's different than other systems in the market because it actually breaks the glass down. So the metered stock is fed into the machine. We have a series of flexible hammers inside the pulverizer that impact on the glass and then also allow the glass to impact upon itself. And glass is frangible. And so as glass is being impacted on and as it's impacting upon itself inside the chambers, it breaks down. It has size reduction. And the non-frangible particles that enter this system, they don't break down in size. They end up bouncing around inside the chamber and literally come out almost whole in size. And so you can see a picture there on the left is what we started with the MRF, glass residue. And the top center is the broken down, the smaller particles, the glass that's been reduced in size. And then the lids and tops and plastic covers and all kinds of labeling that did not get reduced in size, so was screened out during our process by size. And then ultimately, the dirty glass that's been broken down and smaller is further processed into that middle picture, which is the glass sand. So what does a clean glass plant do? It really takes MRF glass residue in its raw form from any MRF, and it begins to break it down and sort it and screen it and resize the glass into a further refined product, depending upon the markets like Wood had talked about that they're trying to serve. If it's filtration, if it's pozzolan, if it's sandblasting media, but the glass is further refined into other products. Additional dust collectors and additional screening beds and additional drying beds and different shaker tables and all kinds of things, all kinds of other subsystems are used to continue the glass cleaning and sorting and sizing process at a clean glass plant. And this is just kind of an example of a layout that Andela has done, where we have taken on the left-hand side, we've kind of broken it down into stage 1 and a stage 2. Stage 1 on the left-hand side takes the raw MRF glass residue and puts it into the system. Again, a cross belt magnet pulls off the ferrous products. A pulverizer in that system reduces the glass particle sizes, but doesn't reduce the non-frangible particles that are in the system. Then we have a trommel that screens it out, and then we recirculate back and continue that process until we get the glass to a certain size, and then it falls out in the bunker below. Now at that point, it still has moisture in it, so then the glass mixture at that point is picked up again, put into another feed hopper, and sent through a drying system. So we try to get as much moisture out of the product as possible. We actually apply a moisture metering device to make sure that the moisture content moving downstream certainly has to be a relatively low level. And then it's sent through a set of shaker tables. And again, it's recirculated, put through an Andela pulverizer. The particles are reduced in size again, and then that process is continued, that recirculation process is continued until the particles get to the correct size to pass on to the next set of shaker tables, where at that point, customers or our clients would have actually sellable product, and they would screen that off at different sizes, or they would send it downstream for further and further processing into smaller and smaller particles. And that is kind of the end of my presentation. I think I'll pass it on to Cindy, who is our CEO of Andela Products.
Thank you.
Yep. Let me end this. And let me turn this off. I think I stopped sharing, Cindy.
Okay. All right, then I will share. Let me see what's. All right. And I'm going to be talking, can everybody see that? Good. I'm going to be talking about some of the markets for the glass. And what's kind of interesting here is that we've talked about, let me back up here. different types of processing, okay? And on the bottom, I talk about glass sand. It's just a sand commodity or an aggregate. And then, you know, with different processing, you can make a cullet, and you can also make a clean glass sand. So these different markets are, you know, depending on how much processing you're going to do, and I'll explain that as I go along. One of the ones that you've seen, maybe heard about on the news, is that I have a customer down in New Orleans, Glass Half Full, that's done a lot of work with just the Tulane University specifying glass sand as a bioremediation, coastal remediation. And it's a simple process, but it's really making an impact on the environment. They have found that they use the glass sand and they are able to grow the grass in it. It's great to hold back the water and the restoring wetlands. Kind of people start thinking about beach remediation. How can I, you know, do something with the glass sand to improve the environment? And this is one of the options. And then that kind of led to soil amendments, which Alfred University is also doing some studying on. And what's interesting about this is that a 2-year study by Olin University, New York, Pennsylvania Market Developments has developed a specification for putting the glass sand with compost to make a stormwater runoff material. That takes the place of, you know, these ponds, and it allows you to make a better stormwater runoff. The glass sand with the compost produces a product that you can grow product in, but it filters twice as well. I should say, you know, the infiltration rate is twice what regular sand would be. But it's still, the glass has an affinity for water. It holds on to the water. So it retains moisture longer than regular sand would. And it doesn't ever degrade. So you don't have it kind of mush over time. So there's you know, physical benefits, there's nutritional benefits because the silica is more readily available for the plants. And it is a great use for it. And that is kind of also just for planting tomatoes, using as a soil amendment or as landscaping because of those physical properties. It doesn't degrade, it holds on to moisture, it filters well. It's a really good material for using in those applications. Now, to use that, you would just have it go through, say, the glass cleanup pulverizer system. So you're going to make a special sand size. You're not putting cullet size in there. You're not putting the larger material. You're putting in a 4 mesh minus, a 4 millimeter minus, a C33 sand size. And that would come directly out of a pulverizer that could be installed at a MRF or at another location. And that is the same for this glass sand and aggregate. It has to be cleaned up per the DOT specs to meet the general bud specification. So you got to get the, you know, the garbage out of it. And if you make it a sand size, you don't have the plastics anymore in it, you know, a little bit of paper residue, but it will meet the specifications for a C33 sand, which means you can use it for a use in construction materials. It's a great backfilling material, number of uses. It's important to know that it's it's an angular product, angular sand, which makes it very desirable for putting under pavers and other applications. But it also has a size distribution so that it will compact. It's not all just, you know, a larger particle. It has the size distribution needed for compaction. One of our customers has developed a product with a glass sand and plastic paver. And this is really becoming very interesting for the industry. And it's a secondary process. Again, you would use the glass sand that comes out of a pulverizer system. And it would be mixed with, they mix it with plastics, and they're making a plastic sand paver. Now, you know, that's kind of popping up over there. They've proven it out, hoping to have this as an available market here in the States in the next year or so. Again, an example of using it in just to make concrete products. One of our customers in Puerto Rico is using the glass sand in their concrete block production. And they're saving money and they're recycling the glass. They're just upgraded because people are bringing in more and more glass. And it makes a better concrete block because it's taking the place of, other sands, which are becoming, well, in the islands, sand costs a lot more money because they can't mine the beaches. It's a limited resource. Now, if you go to the next step, as Rick was saying, you got the clean glass plant. Okay, that's like the stage 2 next step, where you take the sand and you sanitize it, clean it, turn it into a product that you can sell now. It doesn't have odor. It doesn't have a debris, very, very low LOI or debris, or practically none. And then you can go into the markets where you can put it in the bags, small bagging, and sell it at another higher level of value. Two of the most well-known markets are with the demand, and Whit mentioned this, is the filtration media market and abrasives and blasting media market. Because this is amorphous silica, it's not dangerous if you use it for sandblasting. The dust is not dangerous. So a lot of times you hear, oh, silica dust is dangerous. Actually, crystalline silica dust, which is the dirt, that dust is considered not good for your lungs. But when you take crystalline silica and you make it hot enough so it's molten, and then when you quench it, it's called amorphous silica. And it's actually in a liquid form. It just doesn't flow at room temperature. But it's actually the same chemical, but it's the same molecule, but it's in a different formation. But what that means is it doesn't stick in your lungs. It's something we can absorb or we can get rid of. So OSHA considers this a safer material to use for blasting, for construction, for filtration, anything where you're gonna have any kind of dust. You don't have to worry about that. The filtration media, especially, it filters so well. It doesn't clog up. It's in demand. Now we actually have a gap here because there's not enough processing capability that's in place yet to clean up this MRF glass and be able to meet the demand in these markets. But the demand is there. Of course, we want to talk about the glass cullet because we got the bottle bill cullet. A lot of that's going through to TAMRA in New York State and other processors because it's pretty clean. The glass that's coming out of MRFs is dirtier, and if they do some glass cleanup at their MRF, we were talking about removing some of the paper and the fluff and so on, it could be acceptable to go to a processor that's going to turn it into feedstock for bottle manufacturing or fiberglass. But we do need more cleanup along the way. And we have a problem with, how far away are you going to truck it? Okay, so the economics can be a little challenging. One of the ones that we were just talking about here was an anchor tenant. Rick talked about that. And some of the testing that's been going on and has shown that glass sand, that would be pulverized glass sand directly out of a MRF. It has to just be a sand size and sand quality, could replace mined sand in the production of cement. So this is not a pozzolan, which would be, glass that's ground up to be a cement replacement. It's actually a mineral that's being put in on the very beginning. And it makes sense because it's higher silica. They want a higher silica sand. Mine sand's becoming more expensive. And like bottle and fiberglass manufacturing, this actually will save them energy and money. It's a new idea for them because most cement manufacturers own their own sand mines and gravel mines, and they mine their own minerals. But they're also now starting to look for alternative sources. Another industry that's similar to this is in the middle of the United States, not so much in upstate New York, but they manufacture tiles. And when they manufacture tiles, they need an additive like feldspar, just that's imported. It's doubled or tripled in price. And they are looking for, glass sand to replace this mineral. So there's more markets opening up along these lines. Foam glass also takes the glass that's been, gotten the debris out of it, and they're looking for a feedstock. They further refine it to a smaller particle. Then they use the foam glass manufacturing process to make this lightweight aggregate. And that I will call my presentation. Be happy to talk to anybody more about questions at the end. And I'm going to turn it over to Aaron, if he's here.
Yep, I'm here.
There's Aaron. Thank you.
All right. Make sure I get this right. Is showing okay?
It's coming. Oh, there you go.
Okay. Great. So my name's Aaron Potter. I'm a postdoc here at Alfred University. Today I am pretending to be Dr. Colin Wilkinson and Dr. Gabrielle Gaustad, excuse me. I'm here to talk to you about some of the research that's being done at Alfred University to develop new markets for waste glass, especially some of the lower quality waste glass that's difficult to send to some of the other applications we've heard about. So some of those, I'll just give you a brief overview. Foamed glass for both insulation use potentially, as well as concrete aggregate. You can also use recycled glass fines as pozzolan to decarbonize cement specifically. Glass fines for use in soil amendment or hydroponics, and other new projects that I'll talk about that are currently still in development. So the first one I want to talk about is the concrete work that we've been doing here. So Aidan LaCourse just recently finished his master's degree. I just finished doing some edits on his paper. It's looking really nice. What he did was he studied different ways of using the glass in concretes and the effects specifically on ASR. Just tossing a bunch of glass into concrete can be really, really disastrous because the silica species in the glass are too weak and they can dissolve, and that causes this negative reaction called the alkali silicate reaction or silica reaction that causes expansion in the concrete and premature cracking, as you can see in these photos here. What Aidan found was, interestingly, that different colors of glass actually have quite different ASR reactions that occur. Green glass is way, way more effective than, say, clear glass. So that's one interesting thing. But he also found that foamed glass, while it was not perfect and it's not ready to be used just yet, did seem to show extremely good performance, even in large chunks, as an additive to the concrete, unlike most of the other larger pieces of solid glass. And the more interesting thing I think that he found was that green glass fine powder, chromium green, I should say, specifically actually kept the concrete well within the ASTM required standards. And so we are finding that there may be a lot of application for recycled glass in concretes in ways that maybe we didn't think about before. And the benefit here is that if we can use recycled glass as a pozzolan, that means we can actually replace some of our cement, which is what Aidan did for his study. And that means that we've already spent the carbon. It's already been spent for use as the bottle or the window. And so that means that this new cement replacement is actually, in effect, carbon-free for the purposes of the concrete, which is really excellent. And he did a replacement rate of about 20%. So that's a huge benefit there. And of course, I don't have to tell you this, but concrete is a very large industry. So the benefit of this is that the amount of glass we might be able to use for this is really, really high. We're also doing some really interesting work on glass fertilizers. This is an interesting, I was very, I don't know, I was surprised to hear about this, but it's very cool. Plants actually need silica as part of their cells to keep sort of a backbone in their stems and leaves and et cetera. It can also help for the soils, so we can use it as a soil additive. It helps against pests. It helps resistance to external stresses. I think it can also balance the soil pH to some extent. And again, and you can improve the physical properties as well. And improving the physical properties means that they are, say, more resistant to wind and other sort of physical issues like that. And this is especially interesting because by tweaking the way that we treat the glass powder or pieces beforehand, we can actually dealkalize the surface or realkalize the surface, or ion exchange the surface, etc. So we can actually tailor the glass for this glass fertilizer for whatever your application is, or whatever your plant is, or whatever your specific problems are. This also can be used for hydroponics in basically a similar way. As the glass dissolves in the water, you get a different pH, you get a different composition, nutrients, etc. So this could also be a really nice high volume way to use a lot of recycled glass to improve plant quality and ag yields, essentially. So those are the two bigger ones right now, I think. But we have a couple things in the pipeline that I think are really exciting. First, this is mostly finished. We've converted bottle glass, recycled bottles into blowable art glass. This is actually more difficult than it sounds because we need our converted glass to be able to stick to the art glass and not explode when you cool it off. And so this actually does take some doing, but we found some methods that seem to work pretty well. You can see that beautiful vase, not made by me, but with our partner, with some Alfred alumni actually, who are professional glass blowers, and it looks gorgeous. It's not perfect, but we're working on it. Same with this 3D printing. So you can see on the bottom right there, that's something that my undergrad Molly Howlett made this summer. She just started it this summer. And we are getting 92% dense. We're able to 3D print somewhat intricate shapes so far. And I think this comes down to a grinding issue and not so much a fundamental issue. So we're really excited to see where this takes off. And you may be thinking 3D printing, that's a pretty low volume thing. And that is true. That was my critique of it as well. But the idea here is that if we can get 3D printing to work, we should also be able to get something like injection molding to work. And I believe we have either equipment on the way or in the midst of being purchased for that, to try and explore that. With something like injection molding, we could do almost as much precision using very similar, I guess, techniques to make the material work. But we'd be able to make much larger scale, much cheaper, and again, very nice, precise, sharp features on your object. And finally, we have a new grad student who just started here, and he mentioned his background is in tape casting. So tape casting, I don't know if people are familiar. I certainly was not. It's a ceramics technique where you basically pour liquid, a slurry, and then use a blade to just cut it, or to maintain it, I guess, as a conveyor pulls a tape out. So I guess that's probably, suffice it to say, you make a very thin sheet of whatever material you're interested in, then you can sinter it or whatever you'd like afterward. So the idea here is that we can use tape casting to make long, thin glass sheets, potentially for potentially all sorts of applications. And again, this could be something that's a little higher volume than some of the other options. And the complement here is microsphere creation. Spherical particles are vastly superior in slurries if you want to keep the viscosity low, if you want to keep the flow rate high. And so we can also, and so these microspheres, that's another thing that we're working on here. We are able to create microspheres out of basically any glass, but especially recycled glass, because there's plenty of it. And we're able to use that for these things like tape casting or potentially injection molding or something. So because these parts they fill gaps really nicely, but they also sinter really, really well. So thank you all for listening. Here's a bunch of names of people who've been involved in the work here at Alfred. And if you have any questions, you're more than welcome to throw them in the chat, or feel free to email Dr. Gabrielle Gaustad at gaustad@alfred.edu. Thank you.
Okay, thanks, Aaron, and thanks everybody else. So I think now we'd like to open up to any questions that anybody might have for the presenters that we could answer here in the last few minutes. And go ahead, and just a quick note, we will send out a follow-up email with a recording of this presentation, as well as a link to all of the presentations as well, and everybody's contact information. So let's see. So just a comment here. Yeah, there hasn't been a DEC BUD landfill operational cover since November 2017, when the regulations went into effect, and landfills do not have to report. Yeah, I think that's one of the major issues. It's across the Northeast, actually. You know, I was reading a study done by NERC, which concluded that like 75% of all of the glass that goes to a MRF at least is used as landfill cover. And then another significant portion of it is lost. So yeah, I think it's a major problem. And again, there is value to that material. It's just a matter of connecting it to the right markets and in the right form as well, and quality are big issues. See, there's another question. Great innovations. Is there a market rate for a variety of used glass for the recycling, whether clean or unsorted? So I can take just a quick answer, which is, you know, yeah. So there is multiple markets. Cullet is the classic market, which is this glass recycling, and the other ones that we've discussed are glass sands, which are primarily used, as Aaron and Cindy were talking about, into these different types of markets, which, you know, are cement, cement replacement, cement production, as a small aggregate for concrete mixes, things like that.
I think I could add just a little bit to that, Whit, and I think on the market rate, it kind of points to the fact that the industry needs a broker. They need somebody to move the material, you know, into the markets. And that is one of the things that has been challenging, you know, for anybody who has waste glass, to kind of find somebody who can give them options in pricing.
And then there's a question about any types of private sector or public sector incentives for MRFs. The only one that I'm aware of is, you know, there are multiple grant programs that that New York State runs for individual MRFs, but also the new law around containers also has some funding that is for MRFs to potentially invest in, or municipalities to invest in their infrastructure.
I will say Alfred, I don't know how this is for everybody, but if you're in New York State, and you're, especially, I think if you're a academic institution, the New York State Department of Environmental Conservation is the main funder for a lot of the projects that I mentioned about. And they are a huge source of funding for us, and they are extremely supportive of diverting the glass, because landfills are increasingly becoming a problem, and they'd like to stop that now, ideally, if they can. So they've also been a really great source for us.
Thanks for that. We also have some questions around, okay, what are the overall volumes for a business to work? And then what are the economics of getting from MRF glass to the end paying market? So I can kind of take a shot at this. You know, for the glass sand market, you need volumes and consistent volumes. And just because it's a low cost material, and you're replacing a mined commodity, which has a very low cost, but as I mentioned, there's people willing to pay more. You know, so you need sufficient volumes, which is why in the plan that we're working on, we're talking about combining multiple municipal areas and multiple you know, geographies to link together to justify the investment into a facility like what Cindy and Rick were talking about, which is able to clean up and produce the glass that is necessary. And in terms of the end market for people who are paying, I think, at least from my perspective, there are two. The main one is like kind of finding an anchor customer that's willing to take bulk, which, you know, the one that identified is the cement producer in central New York. And, you know, they can take, you know, theoretically up to 20,000 tons annually of glass sand. And then they would ultimately pay for that as well. And then the other payers are in the secondary markets, which are the filtration and the abrasives. So filtration sand, I think the major consumer is going to be, I mean, just take like your average consumer, which is like somebody that owns a pool, and they need to replace their filtration sand roughly 200 pounds every 3 to 5 years. And they, you know, there's a price associated with that. It's just that they usually take delivery of that product in 50-pound bags. And that's the same kind of for the abrasives market, which is commonly used in construction or machining, or used by DoD quite a lot for ships and things like that.
What I could probably answer one question that just came in at the bottom. What do you do with wastewater from the washing of cullet, especially if sewer is not available? Yeah, that was a good question, because that is a clarification to make. So when we're talking about the clean glass process, it is a dry cleaning process. We don't use any water. In the past, you know, there are different processes that have to actually washed with water, but it creates a real problem with wastewater. It also makes the glass wet, and then you have to dry it again, more energy. So we developed a dry cleaning process that basically sanitizes the glass and destroys the bacteria without burning the paper, so you don't have carbon in it. Just getting it just the right temperature, sort of like pasteurizing your milk. You got to get it to a certain point so you kill the bad bacteria. Well, you don't want to, you know, burn it. So yeah, no wastewater.
Right.
And then there's another question about, has glass been tried with asphalt? Yeah, certainly has. That's glass fault always comes back up because it was one of the first uses. In fact, one of our very first pulverizers 30 years ago was down in the Bronx, and it went to Brooklyn, and it made glass fault for the city. It can replace sand in glass fault. It hasn't been adapted on a large scale because of two reasons. One is quantity. Glass fault plants need to have a large quantity for a project, and they don't want to switch from glass sand to regular sand in the middle of the road project. So stockpiling becomes an issue, and the MRFs who have the waste glass often don't have a place to stockpile, you know, 5,000 tons of glass sand in preparation for a road project. So it's a logistics problem. And even in New York City, they used it for glass fault for a while, and then the Brooklyn asphalt plant ended up having to redo their lot, and they didn't have room for a bunker for glass sand, and they quit using it. So there's still that building the bridge, which might be a technology or equipment, a technology challenge or a system challenge, but there's also the logistics of where do you put it. If you're using it as an industrial sand, you have to find out if the users. So if it's going to go on asphalt, it has to be a sand, not a gravel, so you don't have stripping. But you don't see a lot of it because of the quantity, and prices are quite low. You're competing with a local sand. There's not a very tight spec for it.
Yeah, that's really good. On the economics part question, I just want to make sure everybody aware it's a two-stream revenue system for most cases, because the MRF has to pay to get rid of the residue. And so they're willing to pay somebody less than sending it to a landfill. So that's a revenue stream for a downstream MRF processor. And then when they make a product, such as filtration media or sandblasting media or Pozzolan or any other product downstream, there is a value there too. So it's a two revenue system. The profitability of it's going to be dependent upon the competitiveness that they are in the market, how well they refine their process and get their wearables down, and continually improving their systems.
Yeah, that's great. Thanks, Rick. That really highlights that. Yeah, I mean, it's important for MRF operators and for everybody else to realize that MRFs do have a cost, even when they are using this as landfill cover. And you know, the business plan calls for reducing that cost, but still trying to get paid on both sides to make the economics work for the business.
Yeah, and I just wanted to say thanks to the comment from Allison in Columbia University. US Composting I think the opportunity for putting glass sand with compost is, you know, a big volume and a good benefit, and it's a relatively new idea, but we welcome the, you know, partnership with US Composting, and many municipalities have a composting operation, quite often right nearby. And so the possibility of processing their glass into a sand and offering it as alone or as a mixture with their composting for a soil amendment, stormwater runoff, bioremediation, bioswales. It's a great opportunity. It's just, you got to put it out there and let people try it.
Okay, I think we're just at the end of our time here. Just want to thank everybody for participating in the event. And as I mentioned, we'll send out a link with the video recording and links to the presentations as well. And then please feel free to contact us if you have any questions or think there's any opportunities to cooperate. We're definitely open to those types of things. So please feel free to reach out and we can have a chat. So thank you all very much.
Thank you.
Thank you.
Thanks, everyone.